Okay, the purpose for this next lab, we've been talking about electricity, we've been talking about circuits. The purpose of this next lab is really to introduce you to the labs we will be doing on circuits, and it's actually to practice with the equipment that we're going to be using. One of the things you're going to be using is this multimeter, and part of this lab is to practice using this and setting it up, and we'll get to that in a minute. Another part of the lab is using a circuit board, or a lot of times it's called a breadboard, and we're going to get to that in just a minute. And then the third part is to practice setting up series and parallel circuits on the breadboard and measuring those resistances and making sure things are set up. And we're going to get that in just a minute. We're going to go back to the multimeter. We're going to talk about the multimeter for a minute. This thing measures resistance, it measures DC voltage, it measures AC voltage, and it measures current. We're only going to use it to measure voltage and resistance. We're not going to be measuring current because it requires a slightly special setup, and if it's not set up right, you're going to get a nice little surprise when you use it, and I don't like surprises. Things are color-coded. It makes it very easy. Again, like in the other times I've done this, read the procedure on getting the exact details on how to set this up. I'm not going to go through it, but it's pretty well color-coded. The black port, the black plug goes into the black port. There's two red plugs for the red one. We want the volt ohm plug because we're going to be measuring voltage and resistance. The other thing to recognize is obviously the dial. The dial is set at different scales. Whenever we're reading resistance, for example, we want to start off on the highest scale because we don't know what we're going to be reading. And so we start off on the 200 million, 200 M scale. If it doesn't read anything, we move it down to the next lower scale. And this is kind of odd the way it's set up. The one below it is not the next lower scale. It's clear down on the other side of the ohm range. You have to look at it to make sure you're reading it the correct next scale. But part of this lab is obviously to learn how to read the resistance and then try some different measurements. One of the things the multimeter does is it measures what's called continuity. Is there a direct line between the two probes? And we want what looks like the little sound signal, and there's a better picture of it in the lab. We want to set it to that. Obviously the power is on. And when you get a connection, you get a high-pitched beep. You get a high-pitched tone. You might be able to hear it on the video. And that just tells me there's a direct connection between the two probes. And so one of the things I ask you to do is to go around the room and try different things. You can try the desktop. You can try people. You can try the little grommets in the laptop. And I just want you to learn and figure out things that are conductive and things that aren't conductive, where there's a continuous line. It's just one of the tools that we can use the multimeter for. The next step, and one of the things you're going to get as part of the first part, is what's called a resistor. We've talked about these in class. This is what a resistor actually looks like. Are you able to zoom in very much on that, or
zooming?
The electrical component resistor simply looks like this little piece of stuff. It's hard to describe it other than that. It's got little lines on it, but it has a certain resistance. And so one of the things that we're going to do is to practice using our multimeter to measure the resistance of a resistor. And I will provide you the resistors. So you simply move it to the ohm scale and try and get a reading. To get a reading, it's pretty simple. You just hold it, and you can hold it. You can hold it with your fingers. I want the wires to be touching the probes. I start with the highest scale. I see if there's any type of a reading. If not, then I'm going to go down to the next lower scale. Nothing. Zeros. Now I'm starting to get something, but it's not very much. I'm going to keep going down. Now I have still not much. 0.016. I can do better. And I'm getting around 50 ohms on this. And so I had to keep going down through all my scales to get to that lowest scale. And if I overshot it and it overranged, it's going to give me a 1 like that. I go back up a scale. Part of the lab, part of the purpose is to learn how this works. So take your time and understand how that works. Once we get the we measure the resistance of that resistor, I want you to measure the voltage on a battery. A battery has DC voltage. So we want to move the dial to the part where it's reading voltage. It has a V, and it has a dashed line with a solid line. That indicates DC, constant, steady. The wavy line with the V is the alternating. That's the AC. It's the same idea. If we're not sure of the voltage, we start at the highest level, and we just basically hold the probes to our batteries. You can hold on to it. There's not, in these batteries, there's not enough voltage to hurt you. And you keep adjusting the dial until you get a voltage. And this type of battery, it's about 1.6 volts. That's normal. The next part, and this is not necessarily, you just have to be smart about this one. I want you to measure the voltage at an electrical outlet. Now, that's an alternating current, so we want to go to voltage that's alternating. It should be about 120, so I'm going to top it off at 200, and I'm going to stick the probes into the outlet. Now, if you're just holding on to the probes like this, and the multimeter is set up the way the procedure has it set up, it is perfectly safe. If you hold on to the probes with the metal part and shove them into the outlet, do that in somebody else's room, not in mine, because that's a bad day on your part. I would prefer you just don't do it at all. But it's pretty easy to do. We're just going to stick them in the outlet. Stick them in the outlet. Okay, there we go. And I'm getting about 120 volts. No problems. It's very safe to do if you do it right. And obviously we want to do it right. If you're not sure about how to do this part, this is one time during the lab you can come ask me. I would rather you ask me than to do it wrong and to have something kind of blow up like it did last year. Ask Harper. The last part, there's some questions that I want you to look at. There's other parts of using the multimeter that I want you to look at, switching the probes around. When I say switch the probes around, you don't need to switch these around. You can just, if you're taking the measurement on the battery like this, you can just basically turn the battery around and measure the opposite ends. That's all. And I just want you to see what happens when that occurs. To, again, get you a feel for how to use the multimeter. Part 2 of the lab. I want you to learn how this works. This is a little bit different. You're going to get a couple of pieces of wire. And basically all these holes you can stick a wire in. Some of these holes are connected, some are not. And so you stick a couple of pieces of wires in a couple of the holes. Set this up to measure continuity. Talked about that on the first part of the lab. I'm hearing the beep, so I have it set up right. And what I want to see is when I check it with these two wires, if I get a beep, the two holes are connected where the wires are. If I don't get a beep, they aren't connected. And what I want you to do is to figure out which holes are connected and which holes aren't connected. It might take you a little while. Just have a nice methodic approach to checking the holes. I would put the one wire in one hole and move the other wire around. Make sure you cover both sides. You need to be able to know how these holes are connected for the next part, and that's taking several resistors, and I want you to connect them in series or in parallel on the breadboard. You're going to measure the resistance of each resistor. You're going to put them in series. You're going to measure the overall resistance when they're in series. Compare that to the calculated total resistance when they're in series. So you're going to measure them individually, calculate how much they are when they're in series, put them in series, measure it. It'll be very close. You're also going to calculate how much the overall resistance will be when they're in parallel. Put them in parallel on the board. Measure them, measure the resistance. It should be very close. If it's very close, you have it set up correctly. If the calculation and the measurement aren't close, you have it set up wrong here. The whole purpose of this lab is to introduce you to how to use the multimeter, basically what a resistor is and the different resistances we can have, and how to use the breadboard. Because the next lab that we're going to do uses all these pieces of equipment in a little bit more detail. So this is just the introductory part. Make sure you read the procedure. A lot of things, a lot of questions I left out. I just kind of wanted to give a quick overview on how it all works. The only part that I'll answer questions on is when you're doing the voltage check on the outlet. I will answer questions on that to at least make sure that everything is set up right if you have any concerns. So I'd rather you ask than not. Other than that, that's it. That's all. Good luck.